The question is that how much would an investor argue by investing 50,000 rupees and at interest of 7% per annum for 4 years when interest is compounded monthly? So the question is, there is an investor who is investing 50,000 rupees and the rate of interest is 7%. Now they are asking how much he would earn after the 4 years when the interest is compounded monthly. So that's my main question. So I will write all the data first. So the principal is 50,000. The rate is 7% compounded monthly and the time is 4 years. So we know that it's a question of compound interest. And when the question is of compound interest, the formula that we apply to find out the amount, that is equals to P 1 plus R over 100 raised to the power N. Now, because we know that we put all the values, so it's 50,000, 1 plus 7 by 100 raised to the power 4. Because it is compounded monthly, so we multiply the time with 12 and divide the rate by 12. So it will become 50000. It's become 1200 over 1207 over 1200 raised to the power 48. That will become the amount. Now, after this, what we have to do, we just have to use the log table to solve this question. But before that, what we will do here, we divide these values. So it's 50,000. 1207 divided by 1200 is 1.005 and raised to the power 48. So now we'll, because we have to use a log table, so we'll take log both sides. So taking log both sides, that will be equal to, so log A, that is equals to log of the whole value, that is 50,000 multiply 1.005 raised to the power 48. Now we know that the rule of the log, that whenever something is in multiply, so the law of multiplication we apply, so it will become log 50,000 plus log of 1.005 raised to the power 48. So log A, that will be equals to, what is the value of log 50,000 that we have to see from the log table? But before that, what we will do, we will write 50,000 plus the power will come as in coefficient. So 48 log 1.005. Okay, so let's take the log table and we sort it out right now. So how to see the log table? So we have to take the first two values, which is 50, 0th column. So 50 is here and the 0th column is, this is 50. So it's 6990. That is the mantissa. How many values are there before decimal? There is no decimal. So the value is whole 50,000. All are the significant digits. So 5 significant digits are there. We subtract 1, which becomes 4. It becomes 4.6990. Then what we will do, we'll find the value of log 10, 0th column with 5 as the main difference. So that we have to see. So 10th, 0th column that we will see. So let's move towards the log table. So 10th, 0th column is 0. And the mean difference that we have for the 5 one, that is 21. So what is the value here? Yeah, it's something like that. So, wait a minute. Wait. So the value will become, it's 00 and 21. So it's 0021. And we have 1 before the decimal. So if we subtract 1, which is 0.00. So we have to see the 10th, 0th column, which is 0000. And the 5th difference for the main, which is 5, which is 20, I think 1. So it's 0.021 is the value. And we have 1 before the decimal, subtract 1, and which will be 0.0021. So this is how we find out the value. Now, after this, what we have to do? We have to sort it out. So we'll multiply. So wait a minute, let me go back. So it gives you log A, that is equals to 4.6990 plus we multiply these values. 48 multiplies this will give you 0.12. So we add them. So log A, that is equals to it gives me 4.82 something, 4.82, let's say 0. Now we have to find A. So it will go to that side, log will go to that side, become anti-log of 4.820. So how to work out for the anti-log? So we have to see the mantissa. So we'll see 0.82 0th column. So 0.82 is not here. 0.82 is here. So it will be 0.82 0th column, which is 66 607, and for the mean difference we don't have to see, it's 607 something. Okay, and that will be for the characteristic, what we have to see, it's 4. So 4 plus 1, which is 5. So we have 6,607, and we have one more value. Let's 5. So 0. So after 0, because we have 4 plus 1, 5. So after 5 values, we have to put the decimal, which is not required. So amount is equals to 66,070, or near about that one. It's very, it's in your book, the answer is 659, and which is very close to 660, and that's the answer. So that's the amount that we got. So yeah.